Hello guys, my name is Shobhana Gnanaserkhar. My matrix number is 174301. So basically, today's video is actually for the assignment where we have to submit a 10 minutes video that is related to chemistry for our special topics assignment. So what I'm going to talk about is my final year project. My final year project title is the detonation of carbon dioxide using a strontium nickel based catalyst supported by 3 different supports. So my first support is activated carbon. So my second support is aluminum oxide. My third support is the zeolite. So before I start further, we must know our precaution steps, where we have to wear lab coat in the lab and we have to wear sport shoe in the lab and goggles. Now I'm not wearing my goggles because I'm not doing any chemical reaction. So let's begin. So I'll explain more detail about my topic. Okay, so methanation of carbon dioxide. Why do we do methanation of carbon dioxide? Is we want to convert the carbon dioxide to methane, because we know carbon dioxide emission in our world is increasing year by year due to global warming, and due to this rise of carbon dioxide gas in this world, it caused our earth temperature to increase even higher. So what we came up is we have to reduce the carbon dioxide emission. So basically we just convert the carbon dioxide to methane so that methane can be used as a chemical feedstock for further in chemical industries or petrochemical industries. So why did I choose strontium nickel based catalyst supported by 3 different various support? So strontium acting in this catalyst as a second metal because it acts as a promoter, where it enhances the catalyst reaction. So it will enhance the chemical reaction to give more ion conversion. So this is what I'm going to study about. And then why did I choose nickel? Because nickel is basically a good catalyst for this methanation. It is supported by a lot of journals, and I choose 3 different supports, which is carbon and gamma aluminum oxide and zeolite. I want to check how basicity affects the methanation. So how basicity catalyst affects methanation. So that's why I use strontium, because strontium will enhance the basicity in the nickel catalyst. So I will explain to you my methodology. So basically I have to prepare 3 different type of catalysts and then I run the reaction. So I will explain to you how do I prepare my catalyst. So basically my catalyst I prepare through wet impregnation. So wet impregnation is basically just take 5 grams of the support, like aluminum oxide. For example, I'll tell one. It's actually the same thing happens for the rest too. So I'll take 5 grams of aluminum oxide and then I'll dilute it with water, and I mix strontium and nickel. So basically strontium is also diluted with water under 50 milliliter, and nickel also been diluted with water under 50 milliliter of water, and then I add them while it's on the stirrer. So we stir them for 4 hours. Once we stir it for 4 hours, we keep it after stirred, we keep it in the oven. So in the oven we dry it for 2 days. So once dried, we will get like in the form of a powder, but it's not really powder, we have to crush it to powder. So what we do is, once we're already dried, we take it out, we scratch it, and we crush it very fine powder. So once we crush it, we use that powder to calcine. So you can see I show you this is a calcine boat where we put this crushed powder inside and we put in the calcine furnace and heat it up for 550 degrees Celsius for 4 hours. So if for example nickel, for example zeolite and aluminum oxide, we heat it on the normal air, and activated carbon we heat it in nitrogen gas. So once we heat it, we will get the powder. The powder form is more fine, and we can use it it is ready to use it to run the reaction. So why do we need to calcine? We need to calcine it so that all the metal will turn into metal oxide, and then we will run the reaction. So I can show you I've already done my 3 calcined material catalyst, sorry. So this is my 5% nickel zeolite, 5% aluminum oxide, and 5% activated carbon. So once it's already done, we will continue the reaction. So before we do the reaction, I will show you how my reactor room looks like. So let's look at it. So this is my reactor room. You can see we have our online valve where we click the valve and the gas will flow. And then we have our online GC, where this is how the GC runs. In here only we will calculate the methane production, a conversion, and carbon dioxide conversion. Sorry, methane percentage yield. And then this is our catalyst bed reactor. You can see this is the tunnel. You can see the tunnel, right? The chamber. That is the one where we place our catalyst inside it. I'll explain to you how do we place it. Now it is actually, now I've done, I'll explain to you. Okay, so this is my tank, gas tank, hydrogen gas, and my carbon dioxide gas and hydrogen gas. So okay, so I'll explain to you. Basically, how do we put this catalyst into the tube? Okay, so this catalyst is actually will be sandwiched in the middle of the tube. How do we do that? Is we just take glass wool, we put in the glass wool, and then we put 0.02 gram of this catalyst, and then we put another glass wool to support it so that it won't fall down. Then we just fix it into the fixed bed reactor. Why we need to fix it in the middle? Because the heating will be in the middle, so we need to maximize the catalyst heating. So once it's heated, once we already fix it, we will run the reduction first. Okay, why do we need to reduction? We do reduction is because once we already calcine, all the metal turns into metal oxide. So once it turns to metal oxide, we have to return back to metal. So that's why we do hydrogen gas reduction. So we do this in the temperature of 700 degrees Celsius for 2 hours. So once we run the reaction, once we already run the hydrogen gas in the catalyst, all the catalyst will be turned into metal. So once it already finished 2 hours, I'll switch off the hydrogen gas and I'll on back the carbon dioxide and hydrogen gas, mixture of carbon dioxide and hydrogen gas. So the feedstock is 80% hydrogen and 20% carbon dioxide. The flow rate is about, both also it's 30 ml per minute. The temperature that I'm using for this to run this reaction is 400 degrees Celsius. As we know that Salvatore proposed that methanation reaction is better if it reacts at lower temperature, so it will give a higher conversion. So now once we already, just now the hydrogen gas reduction was at 700 degrees Celsius, so we have to reduce back the temperature to our reaction temperature, which is 400 degrees Celsius. So once it's already reduced, then only we can on to start the reaction. So what I do, I run this reaction for 3 hours. So total is 5 hours. Hydrogen reaction 2 hours and carbon dioxide reaction is 3 hours. So I run it for 5 hours total, and through the 3 hours there will be 12 injection. So each injection will be 15 minutes, so that's how I get 3 hours. So once it's already done, I will take out the spent catalyst and I'll see whether the coke is deactivated or not. I mean the catalyst is deactivated or not, and we can even check it through our results whether it's deactivated or not. So that's all, I guess. I'll get my conversion. So far I've already run two catalysts, which is nickel aluminum oxide and activated carbon. So the results actually, for the first injection, the methane production is very high. but by injection it's decreasing. So it clearly shows that my catalyst is deactivating. So I hope that I really will try to produce a more good catalyst so that it will reduce the deactivation process. So I think that's all from me. That's all from me. I hope you really enjoyed and you understand what I was telling. So thank you.